Hello everybody and welcome to Bite Size Biology, and today we are going to look at the digestive system, and this is part 2. So in the last video there we went through most of these main questions, but we didn't really focus too much on the hepatic portal system or the lymphatic system just yet. Okay, so that's what we're going to look at today. So I think we finished up around 2012 last time. Yeah, we've done 2012 there. Okay, so 2011, what is meant by the term digestion, which we've seen, I think was in 2020. It is the breakdown of food. Why is it necessary? Well, there's a couple of reasons there. The main one there is to make food soluble for transport, or for easier transport in the blood. Okay, that's actually two reasons, soluble and transport. Now, distinguish between mechanical and chemical digestion. So, by writing a sentence about each. Mechanical is physical digestion. Chemical digestion is enzymes, bile, HCl. I gave examples. You could, of course, give examples of mechanical digestion as well. Okay, so you know, your teeth, your tongue, churning in the stomach. They're all examples of physical digestion. So you're given a diagram here, not the, I suppose, the clearest looking diagrams, but this is going back to 2011 now, so you know yourselves that the further back you go in the years, the less accurate they look. Okay, so what part of the alimentary canal is labelled W? So this is W here. If you knew this was your bile duct and your pancreas here, and it's connecting to W, well, that had to be the duodenum. The bile duct is connected to X, name X. Okay, so in this case here, we have X here as the bile duct. X is here. X is here, and the bile duct is here, so that had to be the liver. Okay, W itself is connected to the stomach. Okay, so from which part of the alimentary canal does food arrive into W? The stomach. Okay, but the bile duct is connected to the liver. State one digestive function of the pancreas. Has a few, production of lipase being the main one, I suppose. But you could also say it produces sodium hydrogen carbonate too. So either or is acceptable for that in 2011. So that was a full short question. 2010. Draw a label diagram to show the relationship between the liver, small intestine, and the hepatic portal vein. So this one now is really bringing in the hepatic portal vein. So I just took out this diagram here. We have our liver here, we have our intestines, and the intestines connected to the liver. Okay, and that connection, everybody, that is that Y that I have here. That is the hepatic portal vein. Now, the liver needs to get blood itself, okay, because it's like the heart, okay, the heart has multiple different blood vessels, but the only way it gets blood itself is by the coronary artery, okay, so the muscles of the heart get blood, the cardiac muscle. So the muscle of the liver gets blood, okay, by means of the hepatic artery, and then it's removing blood by means of the hepatic vein, okay, so it becomes oxygenated. So just to make reference to those, they're supplying the oxygenated blood, hepatic artery, and the hepatic vein is supplying is taking away the deoxygenated blood. Name a substance transported to the liver by the blood in the hepatic portal vein. Glucose is the main one. And we know lots of glucose molecules in here get stored as glycogen, which is going to be responsible for production of heat and a few other different activities. Where in human body is liver located in relation to the stomach? So this one gets asked every now and then. I skipped one, did I? Yeah, I did. Part 3, everybody, was name the blood vessel that brings oxygenated blood to the liver. So I said that earlier. That's the hepatic artery. There's only one hepatic portal system here that we're looking at. Okay, and that's the hepatic portal vein. That's where you have capillaries at both ends. Capillaries in the intestine, capillaries in the liver. Okay, so the hepatic artery brings oxygenated blood to the liver. The hepatic vein takes away that deoxygenated blood. Where in the human body is it located in relation to the stomach? Okay, the liver is located behind the stomach. Okay, you could have said a few other ones for that, but I think just learn off one of them and be done with it. Behind the stomach. Let's see, where is bile stored as it's been made in the liver? That's the gallbladder. Give one role that bile salts play in the digestive process. Okay, the main one there is to emulsify fats. Okay, now I don't want to see students writing down break down fats, because that's technically not correct. Lipase breaks down fats. Bile emulsifies it. You could say breaks down fats into a larger surface area, okay, but it's a bit of a mouthful. But you would have to, if you're going to say break down fats, you must say larger surface area. If you don't get the marks. Give 2 further functions of the liver other than the manufacture of bile. Well, you've got a few different things. You've got it stores glycogen. You've got deamination, that's what breakdown of proteins and so forth, and red blood cells are recycled there, and heat generation too. Okay, your body has a temperature of 37 degrees Celsius. The liver is largely responsible for providing that heat, and it gets that energy from glycogen for the most part. There's a particularly good question, questions that have not come up in about 10 years, so well worth looking over. 2008, everybody. You can see very similar questions again now. Distinguish mechanical and chemical digestion. So the usual here: mechanical, physical digestion, chemical digestion, enzymes, bile, HCl, something like that. Name a structure in the human digestive system, apart from teeth, which involved mechanical digestion. A couple of things you could say for that. The tongue and the stomach are the more obvious ones. Okay, you can see you're given a diagram and you're given labels there, so you're obviously going to be asked to label the parts A, B, C, D, and F. A is the esophagus, B is your stomach, C is the small intestines, or ileum if you want to say that, be fancy about it. D, over here, is the rectum, F, large intestine, and or colon, E is the appendix. Okay, I've seen a lot of students mix up F and D with that, so just be careful when you're going through it, that you go through it step by step. Okay, describe 2 functions of bile in relation to digestion. Well, the 2 key functions there, everybody, is emulsify lipids and to neutralize chyme, because it contains sodium hydrogen carbonate. So bile emulsifies lipids and neutralizes chyme. In relation to lipase, where is it secreted, where does it act, and approximate pH? Well, we've seen an identical question to that before. Okay, so pancreas is where it's made, it's secreted into the duodenum. It acts in the duodenum, I should say, and it has a pH of 7. So the pancreas secretes it, the duodenum is where it acts, and a pH of 7. If you said a pH of 8, perfectly fine. Symbiotic bacteria, we've seen that, 2 activities that help with symbiotic bacteria. So just to repeat it there, this is in the last video now. So symbiotic bacteria, everybody, are bacteria living in close contact of another organism in which at least one of them benefit. And what do? They produce the vitamins B and K, and they compete against pathogenic microorganisms, which obviously helps reduce those numbers. Okay, that was part 2. Part 3, named parts of the digestive system which are the following are absorbed into the blood. So the products of digestion and water. Well, the products of digestion has to be the ileum, okay, the small intestine, okay, the villi, okay. I would actually specify here the ileum myself for this. And then for the large intestine, because the large intestine consists of a couple of different parts: the cecum, the colon, the rectum. Okay, I would specifically refer to the colon for this. I'm pretty sure though, if you did say it in 2020, the small intestine and large intestine, you would get the marks. But just to be sure, I would specify the ileum and the colon. Name a process involved in the passage of the products of digestion into the blood. There's only one process there of anything going into the blood, okay, diffusion. Going from a region of high concentration to a region of low concentration. V. Explain how the structure you've named in part 3, I, so that's your villi here, is adapted for the absorption of products of digestion. Okay, so the villi is 1 cell thick, rich blood supply, and it contains a lacteal. So, a large surface area too. So, large surface area, a lacteal, microvilli, didn't mention that one cell thick, rich blood supply. So you had quite a few there that you could have said. Quite a few actually. So that was a big question. 2008 was a full question, 60 marks, specifically on one chapter. So a big and important question, okay, and definitely one worth practicing. Okay, let's move on. We're going back to the hepatic portal system again. So you've seen this diagram already. Name X and name Y. So X here has to be the liver, shaped like a liver as well. Y is connecting the intestines to the liver, and that's your hepatic portal vein. Place arrows on Y to indicate. I didn't read all the question here. Place arrows on Y, the hepatic artery and hepatic vein, to indicate the direction of blood flow. Well, Y I have sorted. You can see that blood is moving from the intestines to the liver. Okay, and that's where the nutrients are all being transported from the intestines to the liver, the small intestine to be precise. Now, the hepatic artery, blood is going into the liver. This is bringing the oxygen into the blood. And for the hepatic vein, it's bringing the deoxygenated blood away from the liver. So that's the direction there. Where is X located? The liver, just say behind the stomach. A state or role that organ X plays in the digestive process, like there's loads there. Now it specifically says digestive process, so any mention of heat really isn't acceptable. But it produces bile, which emulsifies lipids. It neutralizes chyme, produces sodium hydrocarbonate to do so. Okay, there's loads there you could have said. Now, 2005 was a really good question. It's been a while now since they've really honed in on the villi. So the diagram shows a large section of the human small intestine. Your A, B, and C, so you're obviously going to be asked to label A, B, and C. So A is the villus. Villus is meaning singular. Okay. B is the tongue in the middle here. That's lacteal. And C here, which is the walls of the intestine. A lot of students got caught in C actually. State two ways in which A is adapted for the absorption of soluble foods. Large surface area, one cell thick, being the key ones. Okay, you could have said others like that contains a lacteal, rich blood supply. Okay, they were just the two that I gave. Name the process by which soluble foods are absorbed. It's always the same here, guys. Okay, diffusion. Okay, any sort of absorption of nutrients into the blood is going to be diffusion. And finally, what type of food is mainly absorbed into B? So B is your lacteal, and that absorbs your fats. Now you could have said fats, lipids, but specifically it absorbs the fatty acids and glycerol, and it brings it to the lymphatic system. So yeah, I think that was the first question now we come across that we were asked for the function of the lacteal. Peristalsis, muscular contractions, everybody. One reason why low pH is important in the stomach. Now that's just one reason. There's actually more than that. To activate pepsinogen, to pepsin, because pepsin is what breaks down proteins. To denature enzymes in, that should say microorganisms there. Microorganisms, okay. The next function is, why is fibre important? Now, I have peristalsis there, but that really, a one-word answer isn't good enough there, okay? It might have been in 2004, but in 2020 it certainly isn't good enough. So I'm going to write down here to aid peristalsis, or to help it, to assist it. Name an enzyme that is involved in the digestion of fat, okay? Something's getting moved around here. Oh, I see what happened there now. My microorganisms over here got shifted by accident. So delete that and put in pathogens. Same thing. Okay. Enzyme is fat, and that digests fat is lipase. Products of it are fatty acids and glycerol. The role of bile emulsifies fats. Okay. It's specifically a reference fat digestion, so you couldn't have referred to the sodium hydrocarbonate. You can't refer to that. Stated role of beneficial bacteria, it said a role, so if singular, you could have said either of those, producing production of vitamins or competes against pathogenic bacteria. Okay, I think that was it. Yeah. So there was a bit there. Part 2 focused more in on a small bit with the lymphatic system, but mostly with the hepatic portal system here, and the adaptations of villi, capillaries, and so forth. They're the questions that haven't been asked in a while. So yeah, look, you've seen digestion comes up quite a lot, everybody. Okay, it's definitely a chapter worth knowing well. Okay, students generally like this chapter. It's interesting for the most part. But just to be careful with the specifics, and that's the hepatic portal system, the villi, and liver, and the glands, I should say, the liver and pancreas. So look, everybody, I hope you took something from that. All the best with your studies, and I'll talk to you soon.